Central Processing Unit, Block Diagram and Functions, Memory Map. NVIC Control and Manage Interrupt Priority. It also helps the power management of a processor. Interrupt is signal generated from CPU machine code instructions or other external source I/O. The processor may suspend its current execution based on the priority of the interrupt. Type of interrupt. NVIC support type: nested interrupt, vectored interrupt, dynamic priority changes, interrupt masking. In nested interrupt, NVIC compares priority of an interrupt to the current running priority level. If the priority for the new interrupt is higher than the current priority, then new interrupt will take over. Else, the current process will continue. In vectored interrupt, when an interrupt is accepted, the process address will be located from a pre-stored vector table memory. This reduces the time taken to search the process address. In dynamic priority levels of an interrupts can be changed dynamic by software. Normally, IRQ interrupt level is predetermined in our codes. However, with dynamic priority changes we can adjust the level even when the program is executing. Mask disguise interrupts temporarily to ensure currently time-critical task can be finished. Masked interrupts will return to the prior level. The difference between dynamic priority changes and interrupt masking is that masking requires the use of special masking registers, while dynamic priority changes occurs by software.
Memory Protection Unit, MPU, allows access rules to be set. Ensures protection against untrusted user program. Able to set the memory regions as read-only regions, to prevent accidental erasing. Isolate regions in memory to specify. The ARM Cortex-M4-based STM32F4 series of high-performance MCUs with DSP and FPU instructions is an extension of the industry-leading STM32 portfolio towards even higher performance. With flash memory, 180 MHz operating frequency. This is the circuit diagram for ARM Cortex-M4 CPU and the pin descriptions for the CPU. Memory interfacing. It consists of memory addressing, address decoding, buffer, memory timing cycle and DMA. A von Neumann architecture, with a single 32-bit data bus carrying both instruction and data. Only load, store and swap instructions can access data from them. There are 5 types of memory as RAM, ROM, EPROM and flash memory. A predefined memory map. Built-in peripherals, such as interrupt controller and debug components to be accessed. Allows processor to be highly optimized for speed and ease of integration in system on chip. 4 GB memory space can be divided into ranges. Internal bus infrastructure. The bus interface consists of code memory buses, access the code memory region. System bus, access memory and peripherals, provide access to SRAM, peripherals, external RAM and external device. Private peripheral bus, access to a part of the system. ARM bus architecture. The ARM Advanced Microcontroller Bus Architecture. An open standard, on-chip interconnect specification. Large numbers of controllers, peripherals. Advanced System Bus. Advanced Peripheral Bus. And the Memory Protection Unit. Allows access rules to be set up for privileged access and user access. When violated, a fault exception is generated. NPU protects data used by the OS kernel and other privileged processes to be protected from untrusted user memory access. Attributes of bufferable, cacheable, executable, shareable. Diagram shows ARM core interface.